Brad, when it comes to designing these positioners, one of the common questions that is always asked from the customer or from us that engage with the customer is the center of gravity and the eccentricity and how it plays a big factor in the design of these positioners. Could you elaborate a little bit on why that information is critical to making sure that we spec that out and get the customer what they need?
Yes. There's actually two different aspects to that problem when we talk about CG. One of them has to do with its offset. In other words, it's a hanging load. And so you need to have a structure that can rotate, particularly in a tilt application, that is going to be able to withstand that torque or hanging load on it. And you have to have enough structure, whether it's going to be a direct drive or slewing ring or something that can hold a significant amount of moment.
And that would be here on this axis, right? The rotational axis off the headstock.
Rotational axis off that headstock, that is correct.
All right.
It's basically hanging off of the headstock.
Mm-hmm.
Now, the other aspect of that is going to be the eccentricity. In this case, it's balanced on that axis, but as far as on the rotate axis at the end of the arm, that itself is not going to be very well supported, and so it's going to have a little bit of hanging load, but it's also going to have a little bit of eccentricity associated with it. In other words, it's going to be off-center. In this position, it's not that difficult because it acts like a forward turntable. But once you rotate it 90 degrees, then you're now hanging the load, but it's also eccentric from that. And so when you do that, it adds torque and power requirements of the motor. And so you now have to balance between how fast you want it to be able to rotate versus how much torque the motor can put out. And most of the time, most servos are 3,000 RPM. And so you're going to be limited on how much of a reduction that you can have.
And that requirement transfers all the way back to the axis one, back into the headstock, right? I mean, once you rotate that 90 degrees.
That is correct. Particularly if you have an item that might be a little shorter than norm, a little bit longer than norm, then the axis on the headstock itself is going to also have an eccentric load as well. And so how far it's off the center depends on how much torque that you're going to have to put into it.
Great, thanks.